We're going to move on to talk about some tests that help us determine if a given series is going to converge or diverge. All right, the first one is the geometric series test. Okay, so we've seen these before. They might look like either one of these. All right, so the geometric series is going to diverge if r is greater than or equal to 1. And if the absolute value of r is less than 1, then the series is going to converge, and we can always find the sum using our geometric series sum formula. All right. So this is a nice easy one that you're really already familiar with. So we want to determine whether the following series converge or diverge. Here we have the infinite series as n equals 1 and goes to infinity of 3 over 2 to the n. We could also write this as n equals 1 to infinity of 3 times 1/2 to the n. All right, we can see here that r is 1/2. All right, so the absolute value of r equals 1/2, and we know that that's less. We can see that that's less than 1. So this series converges. The way we're going to word these is this series converges by the geometric series test. All right, we could find what it converges to, what that series converges to. We could use this formula here with a sub 1 is 3/2 and r is 1/2, but we weren't asked to do that, so we don't have to in this case. And then we look at example B. We have the infinite series of 3 over 2 to the n. Here it's another geometric, but r here is 3/2, which is greater than 1. So this series diverges. Be helpful if I could spell series. The series diverges by the geometric series test. All right. So the geometric series test we can use to prove convergence, or we can use it to prove divergence. It's one or the other. Right. Another test that we're going to talk about is called the nth term for divergence. This one's a little bit more nuanced. All right, so this says that if the limit of the terms themselves, not the partial sums, but the terms themselves, do not equal 0, then the series diverges. Okay, one repercussion of this test is that if a series converges, then the limit of the terms as n approaches infinity has to equal 0. So this has to be true for a series to converge. All right, but just because it is true doesn't necessarily mean that that series converges. Okay, that's a very important distinction. So the nth term test for divergence only can be used to prove divergence. We can never use the nth term test to prove convergence. So if we do find that the limit of the terms approaches 0, then this test tells us only that the series might converge. It doesn't tell us that it converges. We have to use another test to prove convergence. We can use it to prove that a series diverges. All right, so here's a few examples of that. So we look at this series. We have 2n plus 3 over 3n minus 5. And we're going to take the limit of that. So we're going to take the limit of a sub n. 2n plus 3 over 3n minus 5. We can divide both numerator and denominator by n, we could use L'Hopital's rule. Either way, we get this limit is 2/3. Which doesn't equal 0. Therefore, this series diverges by the nth term test for divergence. Notice that, again, we can only prove that a series diverges. Right? The next example, we want to find the limit of n factorial over 2n factorial plus 1. So we want that limit. And what I'm going to do is I'm going to divide both numerator and denominator by n factorial. So when I divide the numerator by n factorial, I get 1. When I divide the denominator by n factorial, I get 2 plus 1 over n factorial. And then when I look at that limit, I can see that this fraction here is going to approach 0. So the overall limit is going to be 1/2, which does not equal 0. Therefore, this series diverges by the nth term test for divergence. The last example here is 3 to the n minus 2 over 3 to the n. So I'm going to take the limit of the nth term here. So to solve this one, I'm going to divide both numerator and denominator by 3 to the n. So I'm going to get 1 minus 2 over 3 to the n over 1. And as n approaches infinity, this denominator here is going to approach infinity, so this fraction is going to approach 0. So I'm just going to be left with 1 over 1, which again does not equal 0. So again, this series diverges by the nth term test for divergence.